Welcome again. This is Mr. Gee with another video that goes over some of the material that we've been covering here in class. Uh, right now we're doing graphing systems of linear inequalities. It's very similar to graphing linear equations, except for having a single solution as a ordered pair. We have areas of the entire graph that will solve the inequalities. So let's go ahead and then read our directions. It says graph each system of inequalities. Rewrite them in slope-intercept form. Be sure to watch for division by a negative number. Remember, if we divide an inequality by a negative number, the direction of the inequality symbol changes. Remember, for less than or greater than, we have to use a dotted line. That means that the points along the line for the equation are not included in this solution. And for less than, equal to, and greater than equal to, use a solid line. We're going to be doing problems 9 and 10 on the back of the worksheet. Remember, again, if we have an inequality with just an x in it, it only goes through the x-axis. If we have an equation with a y in it, it can only go through the y-axis. That's what generates our vertical and horizontal lines. And then if they have an x and a y both, then that means there'll either be a positive or negative slope. So let's go ahead and start with our first inequality. A negative 4x is less than 4. We'll divide each side by a negative 4 to get x all by itself. And when we do that, division by a negative switches direction of the inequality, so that changes to x is greater than negative 1. So let's go ahead and plot negative 1 on the x-axis. It should be right there, and get out our straight edge. So we move it along here. And this is a dotted line because I do not have an equals to bar. And then we read the inequality statement. It says x has to be greater than a negative 1. So all the numbers that are greater than a negative 1 would be to the right. So that is the area that we're going to shade. So I'm going to outline this right here. Now some of you may have become good enough on doing these type of problems that you can wait and decide your shading at the very end. But I'm going to do the whole thing like this so I can make sure that people that are still learning how to do this will not get lost. So this area here in pink signifies all the ordered pair that is greater than a negative 1, irrespective of what the y may be. Okay, let's do our second inequality. That's negative 8y is less than or equal to 32. Now this one will be a solid line because it does have the equal to bar. I also divide this by negative 8. So this will also switch. So y is greater than or equal to a negative 4. So negative 4 on the x-axis is right here. It only goes through the y-axis, excuse me. It goes through the y-axis because there's only a y in the variable or in the inequality. So we'll put this right here and there, and the line should be a solid line. Now, everything greater than a negative 4, so that would be everything this way. Well, the pink already excludes this, so I don't need to shade this. All I need to do is just to shade where it's already shaded, so it will qualify for the red inequality and as well as the blue one. So we're going to highlight this one. Makes it kind of a lavender instead of a blue, a violet. So now this area satisfies both inequalities. Now we have one more that we have to do, and we'll make this one black. So this one will go through both axes because it has both the x and y variable. So we're going to add 5x to each side. That goes to 0, then we divide by 2. So then I have y is greater than 5 over 2x plus 10. So this should be a positive slope. We start up here at 10. We go down 1, 2, 3, 4, 5, 1, 2. 1, 2, 3, 4, 5, 1, 2. 1, 2, 3, 4, 5, 1, 2. And then 5 and then down 2. Now this should be a straight line. And looking here, it should be a dotted line because I don't have the equals to bar. And then we'll decide on our final shading. So that starts up there at 10. Goes down here, all my points line up, so I know I'm doing the right line. And there we go. Now this says everything greater than this line. So all the y's greater than this line. So a y there, I'd want everything that would be shaded up. So it's just this little key area up here at the top. Just that little tiny piece. So right there is my shaded area. And that's the solution, the graph for problem number 9. Okay, now we're starting on problem number 10. And 10 is just a little bit different in the fact that instead of having one inequality with one variable with just an x and then a y, we have two of them that have y's. So that's a little bit different from the other ones that we've done. Let's do our inequality that has two variables first. Let's go 3x minus y is greater than or equal to -5. So this tells us we're going to have a solid line. Let's add 3x to each side. That goes to 0. Then we're going to divide by a -1. So now we have y. We divided by a -1, so that's going to switch directions. So I have a -3 over 1x plus 5. We'll graph this starting at 5. Then we count down 3 over 1, down 3 over 1, down 3 over 1. And I know it needs to go this way because it's a negative slope. And let's just do that several times to make sure I have the right line. So we start there on my y-intercept, go down to my last dot. Looks like they all line up. This should be a solid line. Draw my solid line. And then all the y should be less than this line. So all the y's that are less than this line would be going downward. So let's go ahead and shade this area. This takes me a minute here. Kind of doing a sloppy job here because I'm going so fast. So there's the first inequality. All right. Now we're going to do the next one. We'll do this one in blue. This is a single variable one, and it just has a y in it, so it can only go through the y-axis. So I've got 2y is less than a -4. Divide each side by 2. So that tells me, let me get rid of that mark here, that y is less than a -2. So let's find a -2 on the y-axis and draw the line. It's a horizontal line because it only can go through the y-axis. So that means it's also a 0 slope. Should be a dashed line. And now it's everything less, but it has to be on this side of the red line. It has to be on the left side of the red line. So let's go ahead and shade this solution area in blue, making us a purple or light violet color. There we go. Now we have our last inequality. We'll go ahead and do that one in black. That is y is greater than -5. I don't have to do anything with that one. So there's a -5. I want to do this one in black. And then it's another vertical or horizontal line. So I'm just going to move that down there. It should be dotted because there's no equal to bar. And then it's all the y's greater than a -5, so we must shade upwards above the line. So I can't go above the blue, I can't go to the right of red, and so right there is my final solution right there. Okay. So that's it for this video. There's just a couple of short problems. A couple of things to remember is that if you have a single variable equation or inequality, it can only go through that axis of the variable that it has. If it has both of them, it can go through both. Remember that if we have the y by itself, we have to look on the y-axis to see if we shade above or below. If it has an x in it, we look to the left or right to decide on our shading. If you have any questions, please post them on my YouTube site, and I'll appreciate any comments or any subscriptions. Thank you and have a good afternoon.